A very popular element in many games is water rendering. Gorilla 3D does not provide a water surface component directly, but it is quite easy to set up one. In this tutorial, I will show you the steps to create a water surface and the options to adapt it to your needs. My name is Eric, so let's get right into this. A water surface consists of many individual components that enable a realistic look. We need the reflection of the environment, the surface under the water, wave movements, and light reflections. To take all of this into account, some preliminary steps in a complex material are necessary. We also need a 3D object that allows us to draw the water surface itself. A planar surface is best suited for this. So we add a T-Gorilla plane. Because it uses static meshing, we can therefore increase the level of detail. I will explain later why this level of detail is important. We rotate it on the x-axis around 90 degrees. Set the height to 20 and the width to. To make our scenery more exciting, let's quickly add a procedural skybox with the default settings. And we also add a terrain to test our reflections and refraction. Set the depth to 20 and the width to. And we set the height scale to 3. Then we move the terrain on the y-axis to 0.5. We can generate a random terrain by right-clicking on our component and then select Random Terrain. We choose the hill algorithm. Now we need a terrain material. For this we use a simple Lambert material. And we load a nice texture. Then we link the material to our terrain via the material source property. The preliminary steps mentioned include the calculation of reflection, refraction, and depth information. We solve all of this using render passes. To do this, we first add a T-Gorilla render pass reflection to our scene. Reflection is the image data containing a mirrored view on a scene depending on the current camera position and direction. This step renders the environment with a mirrored camera before the main loop. The result is cached and can be reused later in our material. We now link the render pass to our viewport. In our test, the camera property is automatically set to the design camera. Add our T-Gorilla plane to the ignored controls collection of the render pass. Otherwise, it will block the view of the second camera and everything will turn black. The mirror position property needs to correspond to the water plane position. But we can leave it at 0 for now until we have not moved our surface yet. Finally, we have to determine the size of the reflection area. In almost all cases, this corresponds to the size of the water surface. So we set it to 20. In the next step, we kill 2 birds with 1 stone. The refraction render pass renders both the part that lies below the water surface and the depth information. Refraction is the image data simulating underwater 3D objects, modified by some visual effects called Fresnel effect. Create an instance of the T-Gorilla render pass reflection and link the viewport to it. Because we don't want to appear a water surface itself, we should ignore it. Simply add our T-Gorilla plane to the ignored controls collection again. And our surface position will be the position of the water surface component. Here we can leave it at 0 until we move the water plane. Now that we've made the preparations, let's get to the fun part. We configure our water material. For this we need a T-Gorilla water material source component. and we link it to our plane via the material source property. Next, we're going to link our render passes to this material. On the reflection pass, we select our component for the reflections. And on the refraction pass, we select the render pass for refraction and depth information. Since the refraction pass also provides the depth information, it is not necessary to set the depth pass. Reflections and refractions properties are already activated by default in the water material source. And we will leave the power of both values to 1 for now. But this can be customized as desired. The actual rendering of water is very complex. Besides the render path computations, we also need further textures. One of those is the so-called DODV map. This has a green-yellow appearance and describes how the texture coordinates are moved to generate a wave structure. Wave generation is then based on an internal time calculation and can be adjusted by using various properties of the material. I will get to those later. We also need a normal map that fits the DODV map. Light reflections on the surface are adjusted using these normals. But we can also adjust light reflections by using the optional specular map. Gorilla 3D also offers two optional textures for generating general water foam and foam at the shore. Let's first add a nice foam texture. While the foam texture is depicted on the entire surface, the shore texture is only rendered in flat areas. This is where the pre-rendered depth information comes into play. On one hand, it serves to blur the edges of the water where the water plane intersects our terrain, and it controls the mixing of reflection and refraction. And on the other hand, it allows us to see where the shore is to render the shore texture. The foam and shore textures looking a bit stretched. Let's modify the tiling. Therefore, we go to the bitmaps collection of our water material source, and then to the water foam texture, down to tiling X and Y, and set both values to 8. And we're repeating it for the shore texture. The result already looks quite nice, but how to generate more realistic waves? While the DODV map generates only optical waves in the fragment shader, we can influence the vertices of the water surface directly via the displacement map in the vertex shader. It would generate waves geometrically, which looks more realistic. So let's add a displacement map that fits the DODV map. It is now important that we increase the subdivisions of the gorilla plane. Only if there is a certain density of vertices, the waves will look realistic. When working with displacement mapping, vertices getting shifted. This leads to offsets in refraction and reflection, because in those render passes we rendered with different information. Therefore, you have to adjust the reflection mirror position and refraction surface position by the displacement intensity value. To do so, we create an onCreate event for our form. So select the form, switch to the Events tab, and then double-click on the onCreate event. At first, we modify the mirror position of the reflection render pass. So Gorilla render pass reflection 1 dot mirror position dot point, and set it to the absolute position of our water plane. And we need a typecast to T.3D. And then we need to subtract the offset of our displacement mapping by the displacement intensity property of our material. We subtract the offset because going upwards like the waves do is a negative direction on the y-axis. And we're going to repeat it for the refraction render pass. So Gorilla render pass reflection 1 dot surface position dot point typecast t-point 3D and the absolute position of our water plane and subtract by the displacement intensity of our water material. Okay, start. This looks much better now. But how can we control the shader? Besides the mentioned textures you can individualize, also a few properties are useful to modify the water look. The wave generation can be controlled by the wave speed property, which defines how fast waves are moving. I think they're moving a bit too fast, so let's reduce the speed. The second property is wave size, defining the amplitude of waves, which means how high or low waves are simulated, but this value do not manipulate mesh vertices, only the optical waves. The already mentioned displacement intensity controls how intense vertex shader waves are. Increasing this value makes our waves larger, and lowering the value reduces the effect. Let's set it to 0.5. Often, you like to modify the color of your water. Then you can of course use the diffuse property, so let's change it to a bit more red color. There are also two runtime properties available. So let's get to our created onCreate event of our form. And by the reflection correction value, we can modify the color of our reflection. This is a scaling vector with 4 values for the red, green, blue, and alpha color channels. We can increase the red channel by 2. The same is possible for refraction by the refraction correction property. Let's start and see how it affects the rendering. Okay. The depth intensity value controls the depth map value intensity during computation. By this, we can influence the blending of edges and mixture between refraction and reflection. Foam intensity determines how much the foam is included in the color mixture. The same for the shore intensity property. Shore width increases or decreases the size of the shore where the texture affects. But caution, this is an inverted behavior. If the value is getting larger, the affected area getting smaller. We have a debugging property called output layer. By this we can control the output of each single layer in the shader. Even if it's intended to be used for debugging, you can use it to stylize your look. One property of water is that it can produce ripples. Our Gorilla water shader provides functionality to add those ripples to the surface. Before it can be used, it needs to be activated by the ripples active property. Then you have further settings to configure the output. Set ripple amplification to define the height of the ripple, and the ripple proximity defines the basis value for the width of the ripple. And the ripple decay tells the shader how fast a ripple will end. Ripples are working by a limited number of 3D points on the surface. Imagine those points, for example, as position where a stone hits the water surface. The ripple will then be generated from there. We can add those points at runtime. First, let's assign a mouse up event to our viewport. Here we get the click position, which can be added by the add ripple call. But we can leave it at 0 for now. And done. Let's start it. And click. Each click will add a new ripple, and we can add up to 32 ripple points to the material. Further optimization to our scene is water caustics on underwater sections. Caustics are reflections on a surface produced by the light falling through the water surface and then hitting a ground. To compute this light behavior might get too intense and will need ray tracing techniques, but there is a simple way to simulate the result. We provide a material behavior component for caustics, which can be attached to any default material. After we have added the component to our form, we need to go to our terrain material, then to behaviors, and add a new item. Link the caustics behavior and give it a name. I am currently working with the upcoming version of Gorilla 3D. Caustics will then have more settings available at design time. For example, we can configure a clipping plane that caustics only appear under the water surface. Therefore, we set the clipping plane normal y-axis to 1. We can also control the tiling, so let's set it to 4. And start. Alright. This tutorial gave you a quick overview on the main functions on working with water material. Leave a comment below if you'd like to see more of those tutorials on specific topics. Bye, and see you soon.